the second half of 6.5 is all about doing operations like multiplication, division, and even powers with complex numbers. So when I am multiplying and dividing with complex numbers in trig form, I follow this formula, and this is just my first complex number z1. I'm using r1, theta 1, theta 1. Z2 uses R2, theta 2. So that's just my format for my trig number, and sorry, my complex number in trig form. For the product, you take your R1 and your R2, and you are going to multiply them. So let's see, Z1 times Z2. You're going to multiply R1 and R2, because that's what you're doing with your complex numbers. For the angles, so inside, I'm actually going to add those. So I'm going to take my first angle plus my second angle, and then that'll be plus I times sine of my first angle plus my second angle. So to multiply complex numbers in trig form, multiply your r's, or your absolute value, or similar to your magnitude for vectors, and then add the angles. For quotient, so if I did z1 divided by z2, I would divide my r's and subtract my angles. Assuming, of course, that your second complex number is not just 0, because then you couldn't divide by 0. So let's use that. All right, so for this first example, I'm going to do z1 times z2. So to do that, I multiply my r's, so 2 times 8, which is 16. And then I'm going to have cosine of, and then for my angles, I'm going to add them. So I'm going to have 2 pi over 3 plus 11 pi over 6. Find a common denominator, which would be 6. So this is really 4 pi over 6 plus 11 pi over 6, which would be 15 pi over 6. Which does reduce to 5 pi over 2. So that's my angle there. It's the same angle for sine, just 5 pi over 2. No need to re-add them. That would be my answer in trig form. To be just a little bit more exact, I would take this cosine, this 5 pi over 2 down to an angle that's between 0 and pi. So if I'm thinking 5 pi over 2 would be, there's 1 pi over 2, 2, 3, 4, 5 pi over 2 would land back up here. So that's really the same as pi over 2. If I want my answer in trig form, you're done. If I want the answer in standard form, then I would actually do my cosine of pi over 2. So cosine up here would be 0 plus I times sine up here is 1. So 16 times 0 is 0. 16 times 1i would be 16i. And that would be it for my answer. Again, you could always write these in standard form to start and check your answer, but that would simply be to check. You need to know the rules to actually perform the operation, which would be faster anyways. On the second one, I'm going to do z1 divided by z2. So to start, I'm going to do my r's divided. So 24 divided by 8 is 3. And then my angle is going to be 300 minus 75. So that's 225 degrees. So obviously when it's in degrees instead of radians, it's a little bit easier to add or subtract. But that's it. That's already between 0 and 360, so that would be my answer in trig form. If I wanted it in standard form, cosine of 225, so if you're thinking about your unit circle, 225 would be over here. So my cosine is negative radical 2 over 2. My sine is also negative radical 2 over 2. So when I do 3 times those, I get negative 3 radical 2 over 2 minus 3 radical 2 over 2i. So that would be my answer in standard form. Just depending on what I ask for is where you would leave it. We can also raise complex numbers to a power. So my complex number z equals r times cosine theta plus I sine theta. And I have just a positive number and a positive integer. And if I do z to the n, I'm actually going to raise my r to the n, just like when we were multiplying, we multiplied our r's. When we were dividing, we divided our r's. So when I'm doing an exponent, I take the r to that exponent. For the angles, you're actually going to do n times theta. So whatever the exponent is, you're multiplying that by the angle. So for example, let's make it a little more challenging and start off with z being negative 1 plus radical 3i, and I'm going to raise this to the 12th. So there's my z. I want to find z to the 12th. Before I can do De Moivre's theorem, it has to be in trig form. So to get this in trig form, I need to find my theta and I need to find my r. It does not matter which one you start with. I think I typically start with the r. So when I do that, that's going to be the square root of negative 1 squared plus radical 3 squared. Negative 1 squared is 1. Radical 3 squared would be 3. So 3 plus 1 is 4. Square root of that would be 2. When I find my angle, I'm going to do tangent inverse of radical 3 over negative 1, which would be, thinking about my unit circle, that'd be at 2 pi over 3. Whether I want it in degrees or radians, just follow whatever the directions say, or if it's multiple choice, following the options there. Should be 2 pi over 3, and if I think about 2 pi over 3, that would be in quadrant 2. So that's a negative for the x, a positive for the y, or in this case a negative for the real, a positive for the imaginary. So I have my angle. So what I'm actually going to do, switch colors just to help this stand out just a little bit more. Is take 2 times cosine of 2 pi over 3 plus I sine of 2 pi over 3, taking that to the 12th power. So when I do that, I do 2 to the 12th, and then I'm going to do cosine of 12 times 2 pi over 3 plus I sine of 12 times 2 pi over 3. And you don't have to show this step. This was I was showing so you could see the setup. 2 to the 12th is 4,096. So then times cosine 12 times 2 pi over 3 would be 8 pi plus I sine of 8 pi. That's my answer in trig form. Again, you could always take this down to be between 0 and 2 pi, which would just be just a little more exact, but both would be fine. That would be 0 plus I sine of 0. If I want my answer in standard form, actually do your cosine at 0, which would be 1. Sine at 0 is 0. So 4,096 times 1 is 4,096.